Hi there. Going to continue from yesterday's sort of recap on the mobile app that is really just doing signing in and signing out. I think yesterday we got as far as handling how it works for signing up a new user and signing in. And I'm just going to go through how the streaming portion works. So if we come onto this system and again we sign in as a user, it's down. Okay, let's bring up the server and try it again. So as soon as it's loading up in the background, this list of users will have been downloaded. But it's not as simple as it sounds because it's actually still streaming. So any more users that get added, they'll appear in this list. So how does that work? Well, within the main app, if you get this far, it means that you have signed in. And if auth loaded is set, it's going to set up a couple of more block providers using this multi-block provider. So you can do more than one if you use this. So we've got one for the message block, which is how I'm handling all of the streaming from the gRPC server. And there's also another one for containing the user list. So they're both the providers that are set up, and the child for that is going to be the logged in app. And the logged in app is a screen that essentially is it's containing the various different routes that we can use on the system, which correspond to the buttons at the bottom of the screen. And home is in fact the logged in app. There's a couple of buttons that are not doing anything at the moment. They are just literally placeholder screens. I think the player's screen is, I'm wondering if I'm even actually using this bit of code now, come to think of it. I'm defining it. This might just be a remnant, which would make sense because I'm pretty sure. Yeah, okay. So the logged in app is really all of the, whichever main screen you're on, but the logged in app contains this, which is common throughout. Let me just have a rethink about this. Ignoring that thing for now, we've got our definition for a Cupertino app. We're allowing the scroll behavior to handle on Windows and Linux, so I can drag it with the mouse. Yeah, we're not showing the debug check mode banner, and that's our theme. And we are passing these routes in, so maybe it is doing something. It's a voyage of rediscovery. And then we've got our bottom navigation bar within the Cupertino tab scaffold. Yeah, with the various icons. Home, agenda, groups, and players, and profile. And then in conjunction with that, we have our tab builder. Yeah, I don't think we do need those routes, because all we're using here is the button presses on the bottom to indicate which widget should be rendered in the main view. Yeah, so I think that's all just a remnant. Shall we delete it and see what happens? We comment that out. Oops. Yeah. We don't need the working screen anymore. Okay, let's restart the app. All looks good. Okay, so we have our redefined. Let's actually delete that. Keep it simple. Not a good video, is it? Anyway, let's see if I can edit this out. So, logged in. The logged in app has a it's a stateful widget, which again it does not need to be. So we can remove stateless widget. Yeah. Oh. Type of. Yeah. Do I need to restart that? Yeah. Okay. Bit of tidying up there. I can now see how it's working again. Right, less code, more concise. I've got. Oh my god! I just need to restart this video. I think. Logged in app. The logged in app page is literally just a Cupertino app which has a Cupertino tab scaffold in with a tab bar which has the 5 icons down the bottom of the screen: home, agenda, groups, players, and profile. And then the builder that corresponds with that is going to render either the home screen, the agenda screen, the group list screen, the user screen, or the profile screen. Obviously, it's in the same ordinal position as these guys up here. So if you had a 6th entry up here, then you better add one down here, or else there'll be a failure. Yeah, okay. So if the index is out of bounds, it's going to run this bit of code, but obviously it will never get there. So if we go straight onto the user's screen, which will be obviously this one here, we'll see what is going to happen. It's going to grab the currently logged in user, and it's doing this from the auth block, which, bear in mind, has been it's available down the widget tree because we mentioned it higher up on the main page. So essentially this line of code enables us at any point to find out who the user is, and we're going to run then this function that's going to return a widget, which will be what you see on the screen, and it takes as an argument the currently logged on user. So it's a block builder, which means it's going to be listening to the block you pass in, which is the user block, and its state, very similar to how we had the auth block working. And then if the state is users loaded, I've put some debugs in here just to, for my own benefit when I was designing it, to try to reduce the amount of rebuilds in Flutter is obviously quite a key thing. And by using these print statements, I was just able to see how often it was re-rendering the entire list, which was in fact every time it received a new item, which is not always what you want. Certainly when you're receiving a lot, i.e. when you first load up the list, you're going to get all of the users, and then as it adds Ben, it will add Boba, it will render Ben and Boba, and not efficient. So I've got some clever demounts code on there that handles that in a nice way, and these print statements just allow me to sort of see that visually. So it's going to return a list view, and all it does is it maps through the list of users that are in the state, and for each one it will put out a list tile, and the list tile has got a title, which is the name, font size 24, and then the trailing part is just the user ID. So that's the value we've got over here. Obviously, if the user response is if the state is anything else, it's going to render out what's in there. If there's an error, check internet connection, etc. Otherwise, spin off the circular progress indicator. It's doing something. So that's all it's doing. So it's relying entirely on the state that is in this user list inside this state when the state is users loaded. Now, let's have a little think, because we need to get to the code that says, hey, I need to start streaming. So basically open that connection to the back end, which if you go to the back end within this file, we've got a bunch of go backend functions that I don't think we mentioned in any great detail yesterday, but there's a couple of functions here that you can add a new client to the list of connected clients, and we got the mutex running on here as well, so it'll lock it and then defer it, which means when the function drops out, it'll unlock it. So just to make sure there's no concurrency issues, and the same for remove. List is literally just going to return that list of clients in a slice, again using some read-only locking. And sending a message is going to obviously send that whatever message that we need to push out to the particular stream that's passed in here. If it fails, then just remove the client. So this is the code here. I think we looked at the broadcast messages. This is the thing that runs on the server that's going to go, right, my job is just to listen to all of the clients, and if anything comes in on the channel, push it out to all of them. And this is the piece of code that needs to be executed from any specific client to establish that stream connection. And it takes a protobuf request and a stream, and will return an error if it needs to. So again, this on the protobuf definition will be would be this one. Yeah, so it takes a request and returns a stream of stream messages. And actually a stream message can contain, it has a type, which is the enumerated type we mentioned earlier with the create, update, etc. And it can have a stream message itself of it can either be void or it can be user. And the more protobuf definitions that we generate, we can add that in here. If it needs to stream something else, it can easily do that. But for now, it's just users. Right, so the first thing it's going to do, when you establish that connection initially, the user that's connected is going to want to get all of the users streamed to it. So we could have done that with a regular kind of client server type thing that says, oh, go and get the messages, the users, and then after that start streaming. But it uses streaming for all of it, and I'll show you how it does that. So let's just go back onto the Flutter screen again, because as soon as we land on the logged in app, what's going to happen, is it the logged in app? Maybe it's not the logged in app. Bear with me. Auth loaded. Maybe it's on the message block itself. Yes, it is. So as soon as you instantiate the message block, it's going to run all of this code. That's going to again set up the connection to the gRPC repository. We're passing in the logger, and we're passing in the logged in user, and we're defining this thing here, which is the variable that's going to contain our stream subscription from the client's perspective. These two things enable us to communicate across blocks, so we'll use that in a minute. And when we dispose it, just tidy things up so we lose it. So the constructor for this class is here. It's going to pass in the auth block, logged in user, and the logger. Set the initial state of that message block to message initial, which is just literally one of these abstractions again. So message state is the abstract class, and all of these extend from it. So we've got message initial, message loaded, message error, and message response. Okay. And then as soon as this is instantiated, the first thing it's going to do is to start listening to that stream. And inside the listen to stream code, it's obviously here going to make off this call to the class repository messages stream, which in itself is going to be running this bit of code. And it's going to talk to this initialized stub. Now I had to do something clever on here because it was hitting a null. I'm not quite sure why. I had to do some other sort of stuff. But this is basically the similar thing to the sub that we used up here to connect to the server. And then we're going to use this yield approach to listen to music, listen to messages in an asynchronous way. And the messages are going to come in from there. So this is the call that corresponds to this thingy, stream messages. So we've got, takes in a request in a stream, and it's giving the request here. And the code behind the gRPC protobuf stuff knows to treat it as a stream. So if I come back one from there, now we're listening to that stream. When a message is received, it's going to run this switch statement that is going to say what type of message is it. Is it a create, a delete, an update, or a resync? So at the moment it's just going to be a create, i.e. someone's added a user, or more specifically you've received a message from the server to the client, which indicates that you should try to create something locally. You know, we're not talking about inserting the record into the database. We're just saying you need to add this to your local apps list of in this case users. And then by using which type of message it is, we're going to look at that one of thing we looked at earlier. So if it's a user type that's being added, we can then run this command that is going to talk to the user controller, which if you remember rightly, when we looked over on the main block, as soon as you get into auth loaded, we're listening to the message block, but we're also listening to the users block. So this is saying something has been received inside this block, but we need to manipulate the state from here. Where was we? Yeah. Yeah, and we've obviously got some things to handle, stream errors and the like. So that's not quite it. There's still a bit more, because now we're going to be listening also on the auth block that we passed in. And the reason we're doing this is all the time you're on the app, when you're clicking around, you've still got that connection open to the stream server. And without that little bit of code, if you did sign out, you've still got that stream over. So that's still got that stream open. Now, if you shut the app down completely, it destroys the stream, which is fine. But if you don't have that bit of code and you logged out and you log back in again, you've still got, you then have two streams open, which is wasteful. So by passing in the auth block, we can listen for events again. And if we listen to the one that says you've logged out, then we can cancel the subscription properly and set it to null. And I think the last bit then is how this part here works. So Yeah, okay, so this is just how we handle the starting. So if you remember inside the constructor, we're going to run listen to stream. Again, I'm wondering actually if there's some stuff that we can remove now. Because I think historically I used to have code inside of the user screen. It was a stateful widget, and inside the init state I was adding a, well, this thingy down here. So it looks like I've got, if there's a problem with that, it will try to reconnect the stream by using the same approach that we had for doing things. So to push a message onto the message block of with the event type stream message, and if that was to be received inside the message block, it would say, hey, you need to restart streaming again, which is going to call the same function down here that is going to establish that stream, and then say message loaded, so it's kind of ready to go. So yeah, there's a lot of code going on in this process. And it's obviously overkill for the example, but it is pretty cool nonetheless. Yeah. Well, hopefully that covers it off. In terms of how to basically set up the gRPC server and the connection, create users, log in, and there's definitely some more stuff we need to put on here. I'd like to try and use I think it's called hydrated block, so we can somehow save the user, because at the moment, if I am signed in like this, and if I was to restart the application, you wouldn't know, so you have to sign in every time. So we just need to maintain that state. How we do that, I think it's up. We need to add some more fields into the user, some sort of token or a UUID. I'm not sure whether using something like jQuery or JSON web tokens is even going to be necessary with this approach, but I don't know. We'll have to have a look. Anyway, like and subscribe if you found this useful, and I'll see you again. Bye.